All right, let's talk about logarithms. There's an old Taco Bell commercial, just one of the Yo Quiero Taco Bell dog commercials, where the little dog is running. I think it's up a fire escape and peeks in a window, and there's Alex Trebek talking about, excuse me, there's Alex Trebek playing Jeopardy, and he gives out the answer, and the Taco Bell dog says, "What is a logarithm?" So the Taco Bell dog comes up with the question, um, and it's such a common question that I like to ask. What is a logarithm? By the time you're at this course, you've been dealing with logarithms at least in one course before, if not before, but seldom do I get a student who can answer what a logarithm is. So here's our here's what a logarithm is. My definition of it is a logarithm is an exponent that turns its base into its argument. So how do we read this? We would read this as log base 3 of 52, but should we be thinking of this? I would think of it as this is the exponent that turns 3 into 52. In other words, this would get the job done if it was placed right here, the whole thing. So I really want to encourage you every time you see a logarithm to think of it, if not read it out loud in that manner. This is the exponent that turns 3 into 52, and that's going to help us maybe have a little bit more understanding of the logarithmic rules as we move forward in this chapter. So write the logarithmic equation in exponential form. So let's understand that. I would read this log base 16 of 8, but I would think of it as this is the exponent that turns 16 into 8. But this is equal to 3/4. So 3/4 is the exponent that turns 16 into 8. And I'll tell you how I memorize it. I memorize it this way. Take this, raise it to that, equals this. It had no meaning to me. But this being 3/4, 3/4 is the exponent that turns the base into the argument. So that is all they're looking for on this. No solve. There's really nothing to solve. We're just rewriting it in exponential form. Likewise, write the logarithmic equation in exponential form. Well, ln is log base e. You could really think of this way. Log base e of e to the third equals 3. So we would read this log base e of e to the third equals 3, but we want to think of it as this whole thing, which is 3. So 3 is the exponent that would turn e into the argument. Oh, well, no kidding. That's pretty obvious there. That's terrible e. My apology. I'm not making it any better. Let's try that one more time. Okay? So, again, let's read that the correct way. This is the exponent, and this is equal to 3. So 3 is the exponent that turns our base e into e to the third, the argument. Okay? Then, write the exponential equation in logarithmic form. So I end up wanting log something something equals something. Well, what do we have here? 3/2 is the exponent that's turning 9 into 27. So 3/2 is the exponent. 3/2 is the exponent that's turning 9 into 27. Again, how would we think of this? What is the exponent that turns 9 into 27? Oh, 3/2 is. So a logarithm is just an exponent. This 3/2 is an exponent. It is the exponent that turns 9 into 27. So Really encouraged for understanding. Don't memorize your way through this. Oh, I put this number, A goes here and B goes here and C goes there. Let's understand logarithms this year. Okay, a little tricky here. We could rewrite 1 on e to the fourth as e to the negative fourth equals 0.0183 dot dot dot, whatever that becomes. It's irrational. E is an irrational number. Okay, so what would we say here? Let's talk about the exponent. Negative 4 is the exponent. So negative 4 is the exponent because a logarithm is an exponent that is turning e into 0.0183 dot dot dot. Or log base e, of course, ln 0.0183 dot 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 is negative 4. So negative 4 is the exponent that turns e into 0.0183. Okay, let's try that again. Okay, evaluate the function at the indicated value. So we are supposed to find log base 10 of 10,000. And that's how we'd read this, log base 10 of 10,000. But it's not how I'm thinking of it. I am thinking of it as this is the exponent that would turn 10 into 10,000. Well, what exponent turns 10 into 10,000? Let's see, 10 to the first 10, to the second 100, to the third 1,000, to the fourth. So this is 4. 4 is the exponent that turns 10 into 10,000. So how would we read this? This is the exponent that turns 5 into 5. What is the exponent that turns 5 into, what is the exponent that turns 5 into 5? Well, this to the right is 5 to the first, so the exponent is 1. So 1 is the exponent that turns 5 into 5. Kind of a boring problem, but hopefully boring. All right, this one is so. This is like going to someone, maybe a good 7th grade math student, saying, "Tell me what 7 times 214 divided by 7 is." And hopefully they don't go through the process or grab a calculator here. They're like, "Well, if I multiply by 7 and then divide by 7, I get back to 214." This is the logarithmic equivalent of that. How do we think of this? I know I'd read it log base 2 of 2 to the negative first equals x, but I read it this way. This, which is x, is the exponent that turns 2. This is the exponent that turns 2 into the argument 2 to the negative first. So this being x, x must be negative 1. Likewise, this, which is equal to x, x is the exponent that would turn 4 into 4 to the third. Wonder what that could be. Of course, x is 3. 3 is the exponent that turns 4 into 4 to the third. You just keep repeating it over and over and over again. Trust me on that one. You are going to understand the rules of logarithms and not have to memorize some of the properties later on. Okay, well, that's a big graph. Looks to be that here is our origin right here. The thick line doesn't show up really well, but I'll thicken it. And we're going to go ahead and graph. I think I'll go ahead and graph this guy in red, and I'm just going to do a kind of a mental t-chart with that. By that I mean if I put in 0, 4 to the 0th is 1. So 0 gives me 1. Put in 1, 4 to the first, I get 4. 1, 2, 3, 4. Put in 2, I get 16. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Just enough room up here. And this thing's growing like crazy now. Put in negative 1, I get 1 on 4 to the first, 1/4. Put in negative 2 1/16th, 1/64th, 1 256th, 1 1024th, I think, something along that line. Anyway, this guy is getting sucked down into 0, so we are right barely above 0, and then it just takes off like crazy. Bad drawing. Okay, log base 4x. How are we going to graph that? I know in past years you might have said this is equal to y and then said this is 4 to the y equals x and then chose values of y and done a t-chart backwards. I'm not doing it. I know that this is an exponent that turns 4 into x. What would good values of x be? In other words, if I had 4 to some convenient values, what does x need to be? Well, if x was 4, the exponent that turns 4 into 4 is 1. And if x is 16, the exponent that turns 4 into 16 is 2. And then I'd have to jump to like 64, which doesn't fit on my graph, but I could say if x was 1, what is the exponent that turns 4 into 1? 0 does. How about 1/4? What's the exponent that turns 4 into 1/4? -1, let's go one more. 1/16th. What's the exponent that turns 4 into 1/16th? That's 1 on 4 squared, or 4 to the -2nd. -2 is. Let's plot those. 4, 1, 1, 2, 3, 4, 1. 16, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 2. Let's go with 1, 0. Let's go with 1/4 -1. 1/16th -2. Well, it seems like this might be an asymptote right along here. Can you tell what point they're trying to get across on this problem right here? Here is a big hint. There's our line y equals x. And notice our symmetry here. 1, 4, 4, 1. 2, 16, 16, 2. 0, 1, 1, 0, -1, 1/4, 1/4, -1. These are inverse functions. Good thing to know. An exponential function and a logarithmic function. The inverse of an exponential function is a logarithmic function, and vice versa. So, again, can't encourage you any more strongly. I feel very, very strongly about this. When we see log base 4 of x, we're going to read that as this is the exponent that turns 4 into x. So in this case, I want convenient values of x 4 can turn into easily. I don't want log base 4 of 7. I don't know what the exponent is that turns 4 into 7. I want x to be convenient powers of 4, like 1 and 4 and 16 and 64 and 1/4, values such as that. So hopefully that's helpful for you. There is our 3-2 assignment. If you're just joining us, you're just a visitor here, welcome. Hope that was helpful to you as well.